This is just f of u e to the power minus s times capital T plus u du. Keep going further, I can take e to the power minus s times t out, and so this is f of u e to the power minus s times u du, which by definition is f of s. Right? So if I have a time delayed function, the Laplace of that function has an exponential term attached to it. It's e to the power minus st, capital T, not little t. Capital T is a number, okay? And Laplace of f of s. We're going to make use of this particular derivation or this particular result when we look at composite functions. That is, if I have a function subjected to an input of the following sort. Right, if I have a function of the following sort. Okay, this is f of t. This is capital T. So it's not switched on, but then right after I hit this capital T, it becomes a ramp. So how do I take this particular function, which is what we're going to do in the next class, how do I take this particular function and write it in terms of the fundamental functions that we know, which is the step function, the ramp function, and the impulse function, and then study the response of the system to this composite function. It's a composite function because it's a combination of the fundamental functions. Okay? This is what we will be doing in the next class, and after that on Wednesday I will start second order systems. Thank you. If you have questions, I'm happy to take them.